Dear people, in this particular problem, we are asked to find an expression for power P that is developed by a pump, and they are saying that power P it depends on the height or the head H, the discharge Q, and the specific weight W of the fluid. Yeah. So what I have done is I have just written power is a function of H, Q, and W. Head, discharge, and the specific weight of the fluid. This is what I have written. Now I'm going to be using a simpler method called as the Rayleigh's method to solve this particular problem. Again, Rayleigh's method is not usually advocated, especially when the number of variables are more than three or four. Yeah, it becomes so very complex, and that is the reason why we use Buckingham's pi theorem. Rayleigh's method is just an easier way and also more of a primitive. I wouldn't say primitive. Well, let us just say that Rayleigh's method is mostly used when the number of variables are very less. Yeah. So I've just written everything as if P is a function of H, Q, and W, I've written P equals a constant K. We have no clue what this constant is. Constant K times H power A times Q power B times W power C. All that we have to do again is find out the values of A, B, and C and then substitute in this equation 1. That is all we have got to do. Yeah. And since we are going to be using dimensional analysis, I've got to write all the dimensions of the various variables here. Power is m l power 2 t power minus 3, head is l, q is l power 3 t power minus 1, w. Yeah. The specific weight is m l power minus 2 t power minus 2, and k constant has no dimension. That's why I've written k is no dimension. Yeah, I have written it over here so that you do not get confused. And you might be wondering, oh, where is the dimension for k? Yeah, k is just a dimensionless constant. Okay, so if I substitute the dimensions in equation 1, I get p is I've just substituted all the dimensions, my dear people. H is l and the power is a, q is l power 3 t power minus 1 whole power b, etc. Now I can expand this equation. So the left hand side is as it is, equals l power a times l power 3 whole power b is l power 3b times t power minus 1 power b is t power minus b, etc. So I have expanded this equation. Now let us equate the powers. Yeah, the powers that we have. So if we equate the powers, let us first look at the m term. The m term over here has a power of 1. What about here? There is only one m term, power c. So equal c. So c equals 1. That is quite easy. Now let us look at t. I usually prefer to do m, t, and l because it's easier. Yeah, if you think of it, there is only one m term on the right hand side and similarly only one t term, whereas l there are one, two, three. That is the reason I do it with m, t, and then l. Yeah. So if I look at the t terms, the left hand side power for t is minus 3. So minus 3 equals, what about here? There are two t terms. Fantastic. Okay, the power for the first t terms is negative b, and the next one is minus 2c. Yeah, we already know the value of c is 1. So if I substitute it, I get the value of b to be 1. So now I know the value of c and b. All that I have to do is find the value of a. For that I'm using l. The power of l on the left hand side is 2 equals, the power of l here is a plus 3b minus 2c. Yeah, that is what I have written here. We already know the value of c and b, so we can substitute the values of c and b. And if I reduce the equation, I get a to be 1. This is quite a simple problem, yeah, because all the values of a, b and c are 1. So all that I now have to do is substitute the value of a, b and c in equation 1. That is what we have always been looking for. Yeah, so I get p equals k as it is, h power a is 1, q power b is also 1, w power c is also 1. So I can write this as p equals k times h q w. And in order to find the value of k, we have to conduct quite a lot of experiments, and then we'll be able to see and identify what is the value of k. Is that okay, my dear people? This is Rayleigh's method.